Right. So I'm Christopher Gibson from IBM. I'm for emerging technologies rather than emerging markets. Sorry. So our job, the job of my group, is to look at taking new technology and starting to apply that to real business problems. So it is about taking research, potentially just innovative ideas, and starting to see how we can actually turn those into practical business value. But I think what you've probably been learning from today is having the good idea is really just the start, and there's a whole load of work that you have to do to take that good idea and turn it into something that you can sell. And part of that is the process of commercializing your software, making your software something that's appropriate to actually be sold. So we're going to look at a variety of topics today. Some of this will actually reflect some of the presentations we've already had. But we'll have a look at things to think about before you actually start to kind of set the scene for the actual process of getting your technology to the market. We'll look at what form that might take, how you're actually going to deliver it. Non-functional requirements, we'll talk about those in detail later. Security, which is a really important consideration. How important depends on the nature of your particular application. But anything that includes personal data, for example, personal information, security has to be paramount. Quality and reliability, obviously, people are going to be buying this. Completeness of your code, so have you actually really finished? And I'll talk about what that means in a while. Intellectual property, which we've seen a little bit of already. And then issues like how you're going to support your technology once it's actually out there, and how you're going to sell it internationally. Now this is the starter set. It's really important that when you consider each of these issues and how much or to what extent they apply to your particular piece of technology, do get your own professional advice, and I think intellectual property is a fantastic example of where you do need professional advice to actually help you through this process. This will get you started. So we've seen that it's really important to understand your product and what it's bringing to the market. So you may wonder why I've got this slide up, and it's really down to making sure that you focus as you go through this process on emphasizing your competitive advantage. Now one of the things that you're going to want to do is to look at the competition, look at what's out there. You need to be careful of that, because one of the things that you set yourself at risk of doing is contaminating yourself with their IP. So you might read about your competitor, you might notice a good idea and think, maybe I should include that. Be really careful there, because that could cause you problems in the future. Even actually accessing information on a competitor's product might contaminate you. You might have to sign a license agreement before you can download the spec, for example. So be careful there. Commercialization is a very costly process, and that means you need to focus your attention on the areas which are really important, the things you really need to do to get your product ready. There's a phrase, polishing the nose cone, where you've built the rocket, it flies, but you're really just buffing up that nose cone so it looks really good. That isn't the place to be spending your money. You need to worry about getting the thing flying. That's the important part of that process. Look at your users. Who's actually going to be consuming your technology? And make sure that you focus on meeting their needs, the thing that they're really going to want to do with your technology. That's where you need to be spending your time. So consider things like how expert your user is going to be. Does this need to be really easy to consume this technology? Versus maybe a very niche, very technical product where your user might accept a certain amount of learning, a certain amount of extra effort required to actually get to grips with it. That's the kind of thing you need to understand. So you need to profile your users and make sure you pitch it at the right level for them. So these things to consider before you really start, and they set the scene for the other steps that we're going to talk about. So be very clear how you're actually going to deliver your technology to market. And of course there are many ways, and you might do some or all of these. So a traditional application arrives on a CD, you stick it in and install it on the laptop. That's nice and easy. Maybe you'll do an online service, so access via a web page. Again, there are benefits in doing that. It means there's one copy of the software. You can carry out maintenance, improvements, enhancements locally, and all your users see that straight away. Mobile applications, of course, getting things onto phones, and there you need to consider the specific technologies that you're going to be delivering on, so Android, iOS. As soon as you get onto a mobile device, you run the risk of having to produce multiple versions of your code. Something which is increasingly important is actually delivering your technology as a cloud service. Now, that's kind of like, you can think of that as being similar to an online service. What the cloud gives you is scalability. It gives you globalization, or it gives you global reach. So let's say that you start with half a dozen users, then overnight the thing goes global and you've got millions of users. You've got to worry how you scale up your infrastructure to actually cope with that volume of users. And we see this really does happen with apps. The cloud allows you to do that. It provides that virtual environment that will scale with you. Think about if you're going to allow your users to develop code using your technology. Potentially you're actually producing a new piece of hardware. Alongside all of that, it might be the case that you're also going to deliver some services and consultancy. That's another revenue stream for your technology, which is working with people to help them exploit what you're offering. Now we have these things called the ilities, usability, accessibility, scalability, and the list actually is much bigger than this. These are some of the key ones. These are what we describe as non-functional requirements. The things that aren't necessarily the specific function of your application, but things you have to be concerned about to make sure you're delivering something that people are going to want to use and can use. Usability, I put at the top of the list. So Apple, bless them, have created fantastically, beautifully designed products, and that's raised the bar for everything. Now people expect that kind of quality, that level of design, and we see it from other manufacturers, suppliers too. And so expectations are high on the quality of the product that you're actually going to be producing. So it's really important that you consider not just how lovely the thing looks, but how usable it is, how easy it is to use, how quickly your users can get to grips with it, and can they deliver the job that they want to use your technology for. The best way to do that is really to start talking to users very early on. So as you're starting to commercialize, go out and talk to your potential users and see what it is they want. Run through ideas, your plans, your ideas, your thoughts with them, and get their feedback and see if it's what they really need. Accessibility is really important too. So this is making sure that your technology is usable for the entire user base, and that includes people with disabilities or special needs. And in some countries, it's a legal requirement to actually ensure that you've got those capabilities built in when you sell into certain areas. So that's something to consider too. Scalability, so think about as the use and exploitation of your technology increases, can it cope? So if you've got a database, can it grow very large? If it has supports a number of users, how many users can it support? Make sure that you've built it and tested it for the kinds of levels that you're expecting. Extensibility is considering how people can actually extend the capability of your product through SDKs and so on. And if they can do that, you need to think how that's going to affect other aspects. So could a user add a new function using your SDK that maybe impacts security? So that's something to be worried about. Maintainability is really important too, because as soon as you get users, they are going to start finding problems, they're going to start reporting issues and bugs. So you need to make sure that what you've delivered them allows you to diagnose and fix those problems. So that's about your technology logging information, capturing information, which you can then go and do some analysis on later to try and find the issue. And related to that, obviously, is reliability. So think how long your technology is going to have to stay up and running. So if it's a mobile app, we've all had mobile apps that maybe need to be restarted occasionally or crash or die, and generally speaking that's not too much of a problem. But if you've got some technology that's supporting 100 users, it could be that if that technology goes down, it's having a major financial impact on your client. So you need to make sure that you mitigate that and you're prepared for it. So think about what uptime you need, if you like, for your particular technology. Security is, as I said at the start, really, really important. And there are many ways that security of your system could be compromised. Very simple things like access control, so making sure that only legitimate and authorized users can access the data that your application perhaps is capturing or generating. You need to make sure that you validate all the information that your users enter into your system. So, are they producing or is the data that they're creating actually valid data, data that isn't going to cause a downstream problem? So, you know, can they enter empty fields which are going to cause you issues later? As I said earlier, if you do actually allow people to extend the capabilities of your software, you need to make sure that doesn't compromise security. And you need to think about issues like encryption. So if you've got a network solution, as you're transmitting data across the network, is it encrypted? Does it need to be encrypted? And when it's actually sitting on a hard disk somewhere, again, does it need to be encrypted and protected? Different users of your system will require different levels of access, so think about that. And make sure that if the user of your system needs to take any special steps to ensure security, so maybe looking at things like firewalls to access applications, make sure you're very clear about what it is they have to do. If you've got an online system, an online service, you need to worry about things like denial of service attack. So that's essentially where somebody is trying to not break into your system, but actually potentially prevent others from using it. This is a really hard area, potentially, and it does require some thought. So you do need to think about your particular application and what are the areas that potentially have some vulnerabilities. Now, generally speaking, any piece of software somebody's written, there's a path through it where everything works beautifully, the golden path. And that's fine, but the trouble is users aren't that accommodating. They won't follow the golden path. They'll start to deviate. They'll enter invalid values in a field. And you need to make sure that your code can cope with that. This is one of the ways that people can potentially kind of attack your system. So you need to be very concerned that there's nothing the user can do that's going to cause your application to fail, simply because they've taken a path through it that isn't the perfect path, isn't the ideal path. So there's this notion of something called defensive programming. So that's you writing code that expects people to put the wrong values in, expects them to try and do something they perhaps shouldn't do, and ensuring that you capture those. You also need to look at how you handle any errors that happen as your system's running. So we talked about the fact that sometimes phone applications just die. So you need to make sure that when that happens, that the data on the phone isn't lost, for example. The last transaction is completed successfully, or it's kind of rolled back. Those are the kinds of things you need to be concerned about to make sure that when these things happen, and they do happen, that you cope with them appropriately. And of course the way to do that is not just the development of the code, but it's making sure that you test those situations as far as you can. Now, this is to do, basically. And everybody's seen code that has every now and then to do, I need to do X, Y, Z. This is the time you have to actually go and sort those out. They're the easy ones to find, of course. There's plenty of to-dos that aren't labelled as such, and they're the hard ones. So this is generally the things that, the stuff that isn't overly fun when you're writing code. It's about catching exceptions. So when there's a fault in your code, you detect that and you handle it appropriately. You don't just ignore it or log a message. You need to make sure that you cope when you lose the network connection to the server and the application doesn't hang, it does something sensible for the user. You need to make sure when you try and do a database operation and it comes out with an error code, you cope with that appropriately, and you do something again that isn't going to cause the user aggravation or at worst corrupt the data that your application is actually managing. And also things like data validations where a user is actually entering information, making sure that that is valid data. So if you ask for a postcode, make sure it is a postcode. So that's just a sort of sample list. You really do need to go through your code though and find all those points, all the things you thought I'll do later. And generally this is the stuff that's off the golden path, if you like. Find those and where possible, sort them out. If you can't sort them out though, you need to make sure that you're tracking each of those and you understand that, okay, I don't handle network disconnects very well. It's something I'm going to need to worry about in the next release. So make sure you've captured that and you've recorded it in a proper defect feature management process. So you know you've got to come back to it later and you understand, and you can even kind of warn the user to a certain extent that if they do X, bad thing Y will happen. But if they know in advance, they're going to be much happier than when that happens unexpectedly. Sometimes some of these kind of unfinished bits of code, if you like, can cause potential security problems. So you need to kind of understand that, particularly the ones that you can't sort out, what that issue is and if that's acceptable, introduces an acceptable risk or not. And of course, you need to understand that any you don't do might impact your non-functional requirements, like maintainability, for example. If you don't catch an exception, or you catch an exception in your code and ignore it, when that happens and things go wrong, you're never going to know what happened because your application, doesn't log it, doesn't report it. So by not looking after these areas, you are potentially going to cause yourself further work downstream. Now, of course, when you do get your code out there and you have a client base, they are going to expect you to provide support. And support can be quite costly. It can actually require quite a lot of effort. And it tends to be front-loaded. So what that means is when a user first starts using your application, that's the time that they're going to need the most help. When you release a new issue a new release, again, that's when your user base is going to need the most help because they're going to find things that you didn't necessarily detect. So you need to be very clear how you're going to handle that situation. And then part that's a function of the kinds of users that you've got, how many users you've got. So if you're going to sell your application in a fairly sort of small niche market, it might be that you can provide quite focused one-to-one support. If you're providing some kind of cloud-based service, then you could have thousands of users and you can't talk to them all. So think about the most effective way for you to provide support. So sometimes that could be sort of traditional email, telephone. Sometimes you might charge for support. That is certainly very important to consider. You need to think about what your hours of support are. So if you're selling to UK clients, 9 to 5 is probably going to be okay. If you're going global, of course, you need to think about, okay, well, I've got people in completely different time zones, how am I going to provide the support that they need? Alongside that, think about how quickly you're going to, what expectation you're going to set on how quickly you can turn around issues when they're detected. So how quickly you're going to get back to your clients and make sure that they're happy with the fix that you can find, with the workaround perhaps you can find. A very cost-effective way of doing support is, of course, via the web. So you might set up your own forums, if you like. That has the advantage, so people can report problems in a forum. Your own developers can actually respond to that. But of course that starts to build into a knowledge base of information because generally speaking, if one person sees a problem, somebody else will, if it's documented already in the web and the workaround is known, they can help themselves. And of course with things like forums, your own clients might start saying, I saw this problem and what I did was X, and again that saves your support burden. Think about how you're going to handle updates to your software. So when you do detect a problem and you need to release a patch or an update or a fix, think about how that's going to work. So for mobile apps again, we all see probably half a dozen app updates most days. And of course that is, generally speaking, fixes, sometimes new features. So that's quite easy, actually. That's not too bad at all. Although when you do offer updates, make sure that the update itself doesn't do harm. So let's say you need to change the format of your database. Make sure you don't wipe out the data that the user's already got. So when you issue an upgrade, everything that was there before is still there after, but hopefully a bit better. Something to consider, of course, is that particularly in a small sort of startup type situation, it's the people developing the code that are also the people providing support. And while they're providing support, they're not developing the code. So you need to make sure that you try and deliver your support as efficiently as possible. So things like good documentation, good online resources that can offload some of that support burden are quite valuable and allow you to concentrate and actually increasing the capability of the technology that you're developing. So looking at IP, when you're going to release your code, you need to be very clear about who owns all the code that you've actually produced. How's it licensed? So you've probably got some original code that you've written, your colleagues have written, and you need to understand who the people are that wrote that code. Who they are and what is their relationship to the organisation that you work for. Were they researchers, students, contractors, and so on. And then from that, you need to understand who actually owns the rights to that code. And I guess that there'll be a well-trodden path for code that's been produced out of the university. So that's something to consider. You need to keep an audit trail, so understand where the code that you're using, you're selling, actually did come from, so that you can track and manage that. Make sure you've included copyright notices on your code to kind of indicate the ownership. As we heard in the last presentation, review your code for potential patents and start early, because that does take time. So that's original code, that's code that you've created or your colleagues have created. Where you start to reuse code, of course things get a little bit more complicated. So it could be that you've used open source or code from a third party. Where you've used third-party code, obviously you need to make sure that you've got appropriate rights to use that code. If you haven't, sort that out. If you've used open source code, make sure you're very clear about the license under which that open source was released. So if it's GPL code, for example, that will impact the license associated with your code. And you can find yourself in a situation where you end up giving away some of your own IP by virtue of the fact that you're including GPL code. So be very careful there. But this is really important. Any code that you've reused, make sure you're absolutely clear where it's come from. This is, it could even be examples you've cut and pasted from a textbook or a website. Be absolutely clear that you've got the rights to use that and to resell it, and it doesn't necessarily impact your own intellectual property. This is another example of where potentially you need to work with your legal team, your IP lawyers, to make sure that things are in good shape. And when you do so, that you're not putting yourself at risk from a challenge from somebody who potentially believes they own some of the code that you're including. So hopefully your technology is really successful and you're looking at selling globally. But there are things you need to consider there. One of the most obvious, of course, is that it's likely that to make your product attractive, you'll need to localize it in some form, by which I mean translate it into a variety of languages corresponding to your target markets. You also need consider things like cultural adaptation, and that could be as simple as allowing people to enter an address in the format they expect the address to be in their country. You might well write some fantastic code that takes UK addresses, but you've got to think, what does an address look like in all the countries that I want to sell into, and make sure that you're providing an appropriate interface for that. And there could be certain legislation you need to consider. It depends on the nature of your application and how you're selling it, but that's something to be mindful of. If you sell abroad, then you're effectively exporting technology. And so you need to consider that's something you can actually do. So I'll give you an extreme example, which I don't think applies here, but if you're producing defence technology and you export it, there are clearly some UK processes that you have to go through to get authorization to do that. That's one extreme. But it's possible that some of the technology you're exporting, you need to be mindful of whether or not any kind of export regulations are required. Export regulations, approval, licenses are required. The most obvious example is anything that involves cryptography, so where you encrypt information, for example. That might be something that needs consideration. If you're delivering a solution based in the cloud, or indeed just a web-based solution, you need to be concerned about where the data is actually stored. In some parts of the world, if you have an application that stores personal information, it might be that information needs to stay in that country. I think Europe is an example of personal data. I could be wrong, but Europe is potentially an example of where personal data would need to stay in that region. That may not be the right example, but you get the idea that it's a consideration that the particular data that your application is keeping, it could be important to consider where it is physically located. On the cloud, that's not necessarily obvious. Although generally speaking, if it's a requirement, then your cloud supplier can take care of that. I think the final point is that actually some of your clients might have some specific requirements there. So you might have a UK client that says, great application, but I want to make sure all the data stays in the UK. And you need to make sure that you can accommodate that. So that's a really a very quick run through some of the things that you need to consider. I think it's really important, though, that in each of these areas, certainly the non-technical ones, you do find appropriate advice, professional advice, IP being a good example of where you need to do that. Potentially issues like export regulations, make sure that you talk to somebody who understands it and look at your technology and make sure that what you want to do is okay and is permitted. But also talk to your users too, to make sure that the thing you're building is really the thing they want. It's very easy for technologists to think they know what the users want, and it's not until it's actually out there in front of them that you necessarily will know that maybe you haven't got it quite right. You can sort that problem out very early on by going out and talking to your potential client base, and making sure that you put all of your efforts into producing something they don't want to buy. Okay.
Thank you, Christopher.